ফুল স্ক্রিন মোডে দিয়ে দেবেন। কথা করি তুমি তাহলে একটুখানি অ্যাডজাস্ট করে নিও।
হ্যাঁ, হ্যাঁ, হ্যাঁ। কি দেখা যাচ্ছে?
হ্যাঁ, ইটস ভিজিবল।
ওকে, ওকে। থ্যাংক ইউ।
It's 6:30. Gayatri, shall we start now? Gayatri?
So let us start.
Yeah. So, good evening. Welcome to the
Shubhendu
webinar
join
on
করেছে?
Shubhendu একটু সময় লাগবে. So, let's start then. Good evening. Welcome to the webinar on how machine can learn physics using Python as a tool. I request my departmental colleague, Dr. Gayatri Pal, Associate Professor, Department of Physics, Victoria Institution College, to deliver the formal welcome address. Gayatri, the stage is yours.
Thank you, Shinjini. On behalf of the IQAC of Victoria Institution College and the Physics Department, I welcome you all to this workshop, one day's webinar we have organized. As you know, that Professor Dipanita Chakraborty Bhattacharya is our resource person for today. I'll give you a brief introduction to her before we formally begin. Uh, Professor Dipanita Chakraborty Bhattacharya is an assistant professor, and she was the former head of computer science department of Bethune College. Currently, she is a research scholar or a visiting scholar in the Department of Computer Science, Florida State University in USA. She has done her MSc and MTech from Calcutta University and has about 10 years of teaching experiences. Her research interests include research in machine learning and deep learning, mainly in computer vision. She has worked on a project, Food Safety and Security, on IoT analytics and machine learning at the University of Calcutta before going over to join the University of Florida. And currently, she's working on image processing for generation of high resolution images and trying to apply machine learning in this work. Her publications include a chapter in a book entitled Smart Healthcare Systems Security and Privacy Aspects. The chapter is entitled Impact of Healthcare 4.0 Technologies for Future Capacity Building to Control Epidemic Diseases. Now, I invite Professor Dipanita Chakraborty Bhattacharya to deliver her address, and I think we'll find it a very interesting topic which our students and participants will enjoy. Professor Bhattacharya.
Thank you, Professor Pal, for this humble introduction. So before starting, I will like to thank head of the institution, Victoria Institution College, and the Department of Physics for giving me this opportunity and for arranging such an interdisciplinary webinar so that I can showcase my subject, computer science, and the ideas from computer science which can be applied to physics. So, and I like to specially thank Professor Dashgupta for making this happen. So, communicating with me and making this happen. So, so as you already know that I am from the domain of computer science. My subject is computer science. I am not a expert from physics, so I'm not here to teach you physics, but just give some ideas from my subject so that you can apply it to your own subject for solving problems. So let's begin. I'm sharing my screen. Okay, so today my topic is how machine can learn physics by the tool Python actually. So this something mysterious, right? That how machine can learn. So we human are always a learner. We know that all the animals and different species are also learner. like they learn with the natural uh, course of their uh, growing growing or aging, like like a baby tiger learns to means collect his food from his mother. So we, when we are kid, we learn many things like different objects, of objects, different like studies like ABCDs, numbers, and all that. So learning is the process which starts just after birth of a baby. So we know human, how human can learn, right? So just take an example that how human learn. Then we will shift to machine. We will solve this mystery that how machine can learn. So I'm taking a very common example from your life, and which is a very recent event which is going to happen in your life. So you are almost at the age of your semester ending, and you have exams very soon. So how you find this learning process, right? Like uh, what is the beginning? So first, what happened? Your professor is giving you the teaching classes, like they are delivering lectures on different topics of your subjects, and you are also following the textbooks. So basically, this is your training phase where you are gathering knowledge, right? So from that knowledge, you you have started learning that, and you have to test your skill. So maybe in your classes, teacher can ask you question, teacher can give you small class tests, and you can test your skill. If you are correct, if you are giving correct answer, then your accuracy is 100%. And if the answer is wrong, then you have to go back and train yourself more so that you can perform better next time. And finally, the exam time, right? So in the exam, you will face new questions where you are actually deploying your training skill, and you are trying to answer those questions. So if you think as a student and you are preparing for your exam, so this can be a path which you are following to prepare for a exam, right? So there are training, testing your skill, and finally deployment of your knowledge in the exam. Now, so this is the course how human can learn, but how machine can learn, right? So let's solve this mystery. So this is the brief outline of what I am going to present today. First, we will look into a brief history, then the basic ideas of these terms like artificial intelligence, machine learning, deep learning, and how they are connected in a string. Different machine learning, we will see a deep look through in machine learning and application of machine learning to real life. And from machine learning, we will switch to deep learning as well, and we will see some very basic ideas of deep learning. And then we will move to our main section, that is the application of machine learning in the study of physics. And I will show you some hands-on code which which can give you some direction in this research, right? So the first is the history. Okay, so today we are fond of technology, right? We are changing our mobile phones very frequently as the advancement is going on. Like uh, we want a better camera to capture good selfies, good pictures, right? We are fond of it. We need a good processor. Means we need uh, we need more advanced technology, and we are changing very frequently. So now, mobile, which is just in our hand, can do so many things. Can play music for us. We can see movies on this. We can click pictures. Uh, many things, right? But at the beginning, it is not like that. So basically, the person who thought uh, a machine which can be a universal machine, which can do many things simultaneously. The person is Alan Turing, who is the father figure of today's universal computer, which we are using in different shapes, like a mobile or a laptop or a tab, like that. And his contribution towards this research is, is a milestone itself. This is a machine which is uh, invented at the time of World War II, which is used to crack the communication code of Germans. And we know that at the time of war, every country wants to know the strategies of their enemies. So, Bombay Machine by Alan Turing was doing that job that time. And uh, that time, with that computation power, designing such an algorithm is like really milestone for that era, actually in 1940s. I'm telling about the time of 1940s or the World War II. So the term artificial intelligence is already, means the thought process is already started at that time of World War II. Next, the person, John McCarthy, coined the term artificial intelligence for the first time, and he is also a father figure of this research direction. He coined this term in the year of 1956. Then Unimate, the first industrial robot who has a very heavy robotic arm, weighted 4,000 pounds. So now this kind of machine you can see in any construction area where different heavy duty machines are there. So to drive this type of machine, we need a much intelligent program to do this kind of job. So you can understand that. Next, Eliza in 1964, who is the first chatbot. So you know chatbot, right? Uh, Chatbot is basically a program which can reply your questions, and means this program can help you or can guide you for a particular like particular application or a particular websites. It can guide you that how you have to follow the paths or follow the links so that you can process your job or what you want to do. So chatbot was the first uh, thought of 1964. Next, Shaky was the first mobile robot which has a monitor and a camera which can maneuver all the obstacles near it and can move around. So this is the first thinking of the robotics. Basically, Unimate is the first thinking. Then Shaky as a robot came into the scene in 1969. The next one is Alice, who is a more intelligent chatbot in 1995. So here in this duration, so after 1980, the thought of learning actually comes into the scene. Uh, Means now we are not known about learning, but in course of our talk or our webinar, we will come to know that what is learning for machine. But you just take note from this slide that uh, these type of chatbots can learn from different data or learn from their experience. So this chatbot Alice has a natural language processing capability, and you can give your questions in any language and it can convert it and can answer your question. So this has a NLP capability. The next is a very popular one. So you can see here that Gary Kasparov, who is the legend from chess playing uh, society, he is playing chess with Deep Blue, right? Deep Blue. So is it a person? No, it is a machine. So it is a machine from IBM. So it is a chess playing machine who actually had beaten Kasparov that time in the 1997. So it's how this type of chess gaming program are designed that I'm just coming. I will give you some example and then I will extend you that how this type of machine are designed. Just now I'm just giving you a trip to the history so that you can understand that which field the artificial intelligence can be applied. And you can see from here that it is spreaded like in every field of science and means real life. It is spreaded like every field uh, in your in today's life, and it is started from 1940s actually. So Kismet is a robot which has some emotional capability, like it can understand the human emotions. So we are already in the learning era. So machine already started learning from 1980s. So these robots are specially designed to act like a human, right? So this is the 21st century's inventions. So this is a vacuum cleaning robot. So like if you have Roomba, you do not think about your home cleaning. So you can trust it and can just do anything, like do your own job. So then in the 2008, the birth of Siri, which is a voice recognition system, you already know that it can recognize your voice. You can instruct it to with your voice, and it can search for you. It can browse data for you. It can play music, anything. Like it can even switch off your light or switch on your AC, anything. The next one is the IBM Watson. It is a computer that can do anything human can do, like it can hear, it can talk, it can test, means all the sensory things or the cognition of human that can be performed by this IBM Watson. It is from IBM we can understand, and it is from it is in the year 2011. And next, who do not know about Alexa, right? Alexa, we just take this term Alexa, and Alexa is on work, right? So you can do again many things with Alexa, and it has a voice recognition system as Siri, but it just arrived a bit later from Amazon. And Sophia is the first humanoid robot in 2016 who can think almost like a human, and who can suggest you something like it can give you some suggestion. Its facial expression is like human. It has a speech skill and many more. Amber is the first AI assisted music producer or composer who can produce music for you. Oh wow. So it's good that machine can compose music for us, right? So uh, again, it's a step ahead. And uh, the finally, we are in the time of 2020, so very close to our current time. And here, uh, generative pre-trained transformer, which is a NLP deep learning based computer, which can do many things which can only be done by human. So creating sentence pattern, text summaries, and many things. So these are some invention I have mentioned here, but parallelly many invention are going between this time of from 1940s to till date, and till now this technology, you know, that this machine learning, deep learning is now is almost everyone's mouth. So uh, and it can be applied in any scientific research, and people can think of how to frame their problems so that machine can solve that problem for them. So this is the brief history. So we are actually come up with some terms from the previous slides. So first is the artificial intelligence. So what is artificial intelligence? So it is a basically it is a science that is devoted to making machines think and act like humans. So if our motto is basically automation. So we want that the job of human will reduce, so that with less human power we can work more. And if machine can, what is human? That more intelligently than a sorry, the human can think more intelligently than a machine. That is the barrier. But if we try to remove this barrier as much as possible, but not the overall, because then machine will means rule on us. So this is bad. So then that transformer like thing will happen. So but we are trying to reduce that barrier actually. So artificial intelligence is that science which is making machines think and act like humans. Next, the term is machine learning, which we came to know from the previous slides. So programs that perform better with experience, those programs are called machine learning programs, which has the ability to acquire some knowledge from data, or which can extract some patterns from raw data. The next one, we will come to it. It is new for us, artificial neural network. Basically, this is the technology which is used by deep learning. So as we have mentioned the term deep learning already, so I'm just giving you the idea of artificial neural network. Basically, it is the network which is just trying to mimic the network in our brain. So we know that in our brain we have billions of neurons, and they are communicating with each other through electrical signals. So anytime we see a new things, our neurons are activated and trying to capture the information from it. And artificial neural network is just mimicking that network structure in our brain, which is very complex. But we are trying to, means again, we are trying to learn that structure and we are trying to replicate it through artificial neural network. And deep learning is basically using this type of neural network. And deep learning is basically a learner like a human which can see anything and think like a human that what is in it in that data. So deep learning tries to learn any type of data, text, audio, image, video, human without any human intervention. But you might think that how it is possible, means uh, how our sensory organs work, how we think when we see something new. So can machine take that, uh, like, means we view the thing, like how we view the thing, can machine view the thing like that way? So this is the mystery, that how machine view the data, basically, means the text, audio, image, video, and like this. So let's explore. Then in this slide, I tried to show you the relationship between this. So from the previous discussion, you have got the idea that artificial intelligence is the first thing which came into the scene from the very beginning. That's from 1940, that people are started thinking that yes, the computer programs need some extra, which is not very much common programs, common functions, common mathematical functions, but we need some extra intelligence to push onto that codes, onto that program, so that it acts like a human and
Sorry, our speaker has some network issues, so please bear with us. Just give her some time to rejoin. Due to some technical problem, she left the meeting. Just wait for a few minutes, she will rejoin. Sorry for the disturbance.
sorry, my net connection was gone for some while. uh, okay, everybody there? Can I start again?
Yeah, sure. They're waiting for you, eagerly waiting for you.
Oh, thank you, thank you. Uh, okay. So, I'm not sure my screen. Is my screen visible?
Yes.
Okay. So, just take some while to think about this problem. So, I can read out the problem for you, that you are on the bank of a river with with a boat, a cabbage, and a goat and a wolf. So, your task is to get everything to the other side, but you have some restrictions that uh, only you can handle the boat. So, boat and you is basically same, and when you are in the boat, there is only one space left for another item, and you can't leave the goat alone with wolf, right? So the wolf will eat the goat, so you will lose your item. So, and also nor with the cabbage. So or something will be eaten. So just think and give me an answer, that how the moves can be happen, like how we can how we I can move from one side to another side with one item. Please feel free to unmute yourself and share your idea. I know this is a very simple one. So, please and give your idea through audio, uh, because if you put it in chat box, I cannot see it because I'm already in the slideshow mode.
First, we take the goat to the other side and
Okay.
then go back for the cabbage. And while coming back with the cabbage, we take the goat again on the boat and
Right.
then get back to the side and then get the wolf on board and on the other side and then the goat at last.
Yes, thank you for your idea. Very good. I will appreciate your answer. And so, how you frame that rules for computer? So, human can very easily answer this type of question, but for uh, for computer, you need some programming or need to give this type of moves to the to computer so that it can answer this type of question. So how we will frame that? So here I have taken uh, one beat for each item. So starting from the left, uh, this for boat, and then it's for cabbage, goat, and wolf. So starting from this state, so this is the one state of the machine. So starting from this state, so all items are in the initial bank, and we are starting our journey. So these moves can happen. So I don't know the name who answered the question, but as he said, we have to move with the goat
He is
first.
Anurag Srivastava.
Thank you,
Anurag
Anurag,
Srivastava.
thank you, Anurag, for your idea. So first, the goat will go to the other bank. Means we will take the goat. Uh, then we will take the cabbage. But when we are putting the cabbage into the other side, we will take the goat with the boat, and next we will leave the goat to again to the initial bank and take the wolf, and finally the goat. So the correct path is this. So next this, next this, next this, then this, then this, and finally, this is the ultimate, this is the final state of the machine, which is the successful state. But you can see I have shown here with pink color that these are the wrong moves. You cannot take these moves. Then this can happen. You can violate the restriction. So this is basically a state diagram of a machine. And when you have to design a computer, first you have to build this type of state diagrams. Then you can program according to these moves. So the artificial intelligence is basically uh, forming this type of rules and putting it to the computer, so that computer can follow these moves and can reach to the successful state, the final state, right? Okay, so from the previous discussion, we are already known that AI can be applied in different fields of our life. So in robotics, we have seen many robots there in our history, which are come into the scene means gradually, and they are more advanced. We know, and in entertainment, we have Siri and Alexa like recognition system, which can give us some entertainment. Very important one is e-commerce, where the customers likings are basically learned by the system, and they offer uh, they offer the goods of their choice accordingly. So I'm coming to this type of examples in the rest of the slides. I will use this type of example uh, means again and again, so you can get idea from that. So stepping towards learning system. So why I'm telling that learning system? So first I am telling artificial intelligence, then the learning system. Why I am designating this two term? Because when we started thinking about AI, that time learning is not in the scene, was not in the scene. Means then the aim is to solving complex problem, and there is a rule based system where there is a huge knowledge base, and actually we build rules like this, a bunch of rules, and we put this set to computer, so that computer can take decision accordingly. So basically how human is thinking, that thinking is induced in the system so that it can work accordingly. But that time machines do not have learning ability. So AI starts with rule-based systems where computers are explicitly programmed with a huge knowledge base to take all possible decisions. These are called expert system. But there are limitations of this rule-based system, because there are some problems, like for some complex problems, the rule base become huge, and which is called combinatorial explosion. When this rule-based system grows huge, we cannot handle it very easily. So that is a challenge for researcher to means build this type of rule-based system. Then the concept of learning came into action. In machine learning algorithms, what we learn from data. We know that our computer is also named data processing system. So it can manipulate data, it can also learn from data. But what data? How the data is represented? That is very important. The data can be in different shapes. As we know, as we are the users of internet. In internet, we know we have data like we have text, means we have textual data, websites with means a huge number of huge uh, means storage of text, and also images, because when you open our websites, you can see there is a text section, there are image section, some videos are there. So the data means for computer is text, audio, image, and videos. So how they learn from this data? Let's see. So first, just try to understand the machine learning paradigm. Why it is different from the classical programming? What is the difference between the classical programming and the machine learning? As I'm telling you, that rule-based system and all that. So for those systems, what we are providing to the computer, we are providing the rules and we are giving the input data. So applying the rules, the program tries to answer our question or tries to follow our instructions. But in machine learning, it is some way reversed. So now we are giving machine only data, input data and output data. So data and the answers. And machine tries to learn from the data and tries to know the mapping between the input data and output data, and trying to acquire the rules, the mapping, the function. So this is the machine learning paradigm, which is very much different from the classical programming system. So I have just summarized what I have uh, told you just now from the previous slides, that machine learning is using data to answer question. It tries to learn the mapping between data and answers. And it is basically, so the term machine learning, machine cannot learn, like, so there is algorithm. There are many algorithms which are actually in the process of learning. The algorithms are trying to learn from the data. And as much as data we are feeding its performance are going better and better. So if we take the formal definition given by Tommy Mitchell, a computer program is said to learn from experience E. Experience means here the amount of data we are feeding it with respect to some class of tasks. So obviously, when we are talking about algorithm, so the algorithm has an objective, has a means for a particular problem or particular task, the algorithm is designed. So that is the T. As measured by P, P is the performance measure, because it is important for learning. Like in the first slide, I have told you that when you are in a training phase, you must test your training skill so that you can know that you are in the right track or not. You must assess your learning skill from an expert. So that is very important. So this performance is very important in case of learning. So machine also take this performance measure to do better, right? So here I have given a example of recognizing a spam mails. So you know Google can filter spam mails. So how they do this task? Uh, they use some kind of learning. Means basically not very much learning, because they use some kind of patterns in the mails, some kind of phrases, and try to match those phrases uh, which should be there in the spam mail, and it basically searches for those phrases in every mail, and if it finds it, then it put it to the spam mail, and if it's not, then you will see it to your inbox. So here the T is the task for recognizing spam mails. And experience means data. Data means all the mails and the levels, whether it is spam or not. So already the Google has a bunch of a big data set, means mail and their levels. So from that it tries to learn the pattern, that what uh, is the content of a spam mail, and if it is there in some mail, then it will call it a spam mail, and if it is not, then not a spam mail. So again, how many mails are correctly identified as spam? This is the basically performance. So every time it is measuring its performance and trying to do better. So you can see here in machine learning, all problems are data and all solutions are functions or maps that takes input vector and return output vector. So I want to emphasize on this term, input vector and output vector. So what is it? So you know that machine cannot understand, uh, means machine cannot view the image as human can view that image, right? For machine, it is just only data values, that is numerical values, that can be either in a real value or integer value or something like that. So how the values are structured? So you know, for images, for grayscale images, it is like a matrix, and each cell is a pixel, and each cell has an intensity value. And if it is RGB, then it has three channels, so the dimension will extend. There is a third dimension, and that is 3 for R and G and B. There are three channels, and for each of them, there is a 2D matrix, and each of the cell is containing the intensity of that particular pixel. So for a computer, the image is actually is a either is a two-dimensional matrix or is a three-dimensional matrix. So we know matrix means vector. Uh, it's not a scalar value. It has dimensions. It has more than that. So it is a vector. So output is also a vector, because here in this example, if you think about the spam mail, so it has two classes, so spam and not spam. So it is not a scalar value, it is a vector value, so it has two values actually. So this way we can think about the data, that how the data can be represented for computers. So so just I like to for the spam mail, it is either 0 or 1, it is scalar value for the output. But you can have, like, for other problem, like to identifying the numbers, like if you want to learn the different digits from 0 to 9, and if machine are fed with a image of a number, then it can tell you that whether it is 0 or 1 or 2 or 3, like that. We are coming to that example. So that time the output will be a vector. So it's from 0 to 9. But for spam mail, it is only a scalar value. The output will be only a scalar value. Either it is 0 for not spam and 1 for spam. So output can be either scalar or vector. So now moving towards next slide. So when we use ML, so I think from this you can get some idea that why we are shifting to, means our thought is shifting to the learning from the very means the rule based system, which is which was started at the time of 1940s. How we are shifting towards ML, because we know that when rules are in huge number, they are difficult to extract, and in some context, in some situation, it is really means it cannot be, we cannot generate this kind of rules, because the situation are itself very hazardous for human. Like, we want to navigate in Mars. We do not know what is happening there. So we have to uh, rely on the machines, that what machine is viewing, accordingly, it has to take the decision that which direction it will navigate. Or deep in the ocean where water pressure is too high for human being. Human cannot go to deep in the ocean. So, but the machine can go. Machine can go and can take pictures and can move according to their means, can take decisions that which direction it should move, or where there is obstacle, right? That. So in this type of situation, we cannot rely on rule based system. We have to uh, rely on machine learning. So there are also we can see that uh, this AI and machine learning is not different. Basically, machine learning is a subset of AI. So in the fields where AI can be there, so machine learning can actually do better on that particular fields. So you can see the examples of the application like email, spam, and malware filtering. Self-driving car is a very important example in this regard, because nowadays we know Tesla is in the road. So Tesla is driving the car without a human driver. So, but if you think that this type of problem, if we think this type of problem as a rule based system, we cannot frame rules, because driving is such a job, we cannot means bind it to a particular number of rules, because for every driver the thing is changing. For every situation the thing is changing. There every situation can be a challenge for that particular self-driving car, that how it can cope with it. So from the experience, from the data, that previously the expert driver, how they have reacted to that situation, so that data helps the self-driving car to uh, grow their experience time by time and do better, because we know that Tesla has made many accidents also, but it is in its learning process, and it can do better by the time. So I'm not going to all these fields because it will take much time. So let's move to uh, uh, next slide, and it will give you a better idea of machine learning, that what are the types of machine learning. So supervised learning. So when we are kid, that time, how we learn, our parents keep us notified that, see, this is apple, see, this is a banana. So we captured the image of apple in our mind and put a name to it, a label to it. Yes, this is apple. So now when we are accompanying our parents to a market and we see there is apple, we can tell our parents like, see, mama, it's apple. So like this way, the kid started learning. So this is called supervised learning, where you are already guided by a expert, that yes, this is it, this is in this class, this is in this class, and right, like this way. Examples are speech recognition system, optical character reader. So speech recognition system, we know that for each means for each word, how we are pronouncing that word, like a, we are pronouncing like this, a, so it has a tune. So uh, for this tune, the label is a. So like this way, for b, this b. So machine captures all these tunes with that levels. And for optical character reader also, for each of the character, how the barcode will be look like, that is already there in that system. They're actually trying to match that particular pattern, or a particular pattern to the new data, and trying to trying to categorize it. So from this image you can see there is sorry, there is circles, there are plus, there are stars, and classification means we want to classify this types of data, different types of data, to different classes. What is unsupervised learning? So now the supervision is not there. So you are not uh, told that yes, this is it, this has this category or something else. Like uh, take as an example that when we are kid, if someone gives us like different items of different colors, now they tell us that please arrange this item. So what a kid will do, either it will match the color, like the red items in one section, green items in one section, blue items in one section. So how it is looking into that problem? It is matching the color, means the similarity. The colors are similar, so put it in one section. So we don't know from the view of the color, we are trying to uh, grouping the items. We do not know the types, but from the similarity, we are trying to group the items. So it is used like grouping customers, like the recommendation system. So means everyone is now basically a user of recommendation system, that uh, when you are means if you are interested in electronics goods, so Facebook will give you, like if you searches for a electronics goods from Amazon or from Google, you have searched it. So Facebook will recommend you some like laptops, some new phones. So recommendation system is actually grouping the customer according to their choice of goods, like which item the customer has interest. So that way the customer are grouped, and the item suggestions are coming according to that grouping. Like detecting new diseases. So if there is a similarity of symptoms uh, of some already treated diseases, then doctors will treat the new disease with the previous experience. So if we can group the different diseases, then the treatment can be somehow uh, similar. Somehow doctor can start the treatment with some idea that yes, this way it can be uh, treated, or like this. So these are some examples of unsupervised learning. There are other types of learning as well, like generative approach, where new data can be generated from the previous data experiences. So machine can generate, like for example, face generation system, where a machine can generate new faces when you are feeding the images of faces to it, a huge number of images to it. You are feeding that data, and actually what machine trying to learn is the pattern of the face, like you have two eyes, where it will be positioned, so the position of the nose, your mouth, your ears, and from the face pattern it will try to regenerate different faces. Semi-supervised learning, which is again very important in this research domain. So here it is also called active learning. Uh, in this type of learning, we know that we have huge amount of data. Actually, Google uh, processes petabytes of data every day. Means some petabytes of data every day, Google. So you know that means how means the unit goes higher and higher every day. So you can understand that how much means what is the amount of data now in the internet. So we have so many unlabeled data actually. So labeling those data by human is almost next to impossible. So the concept of semi-supervised learning is that if you have a small amount of labeled data, then you can use that experience to label the other big amount of unlabeled data. In self-supervised learning, machine is actually by itself trying to learn, means the historical data which is already labeled by uh, by the algorithms or the machine, that is used on on the unlabeled data so that it can label that thing. So here machine is actually doing that job. In semi supervised learning, you are telling an expert to label the data, but in self supervised learning, the data already labeled by the machine is used in next phase. Reinforcement learning is very popular one nowadays in uh, like designing games. And you know about the gaming is a big field, and almost all of us play games in our mobiles, laptops, and uh, means tabs. So gaming is a very interesting field in this regard. So where the reinforcement learning is used, so the moves of the games are learned by, are adapted by the machine, by the program, as they learned with the human, with the experts. They come to know different moves and they tries to adapt that moves and trying to do better by the time. So this is the reinforcement learning, and basically it is a reward based system. So every moves it was taking, for that moves it gets some rewards. So whether means someone is telling that yes, you are correct, you are right in path, so you will uh, get a good. So when we are kid, so we are very fond of that comment from the teacher, right? So if teacher gives us good, then we are very happy. If gives very good, then we are too much happy. So uh, that type of reward is very important. So for appreciating you to learn, right? So same thing happens for reinforcement learning. Now I'm coming to the types of supervised learning, because this is very important, because this two problem are very much like associated with your subjective problems as well. So classification, regression. So regression is basically, you can thought of a fitting thing. You have done curve fitting like that. So you have data points, you have many data points, and you are trying to fit a function. Here we are trying to fit a line on that data set so that we can predict for new values. So this is regression. So uh, where we are trying to fit a function to the data to predict new values. Basically, it gives output a real number data. Uh, the very important applications are stock market prediction, house price prediction. So you know that stock market prediction, which is a time series data, where means is a very means interesting field, and every people who are actually contributing in this stock market, they are trying to see that what will be the stock next day. So very important problem as well. So regression, So already we have means time series data for the stocks, and from that data we are actually trying to fit a function to that and trying to predict the means tomorrow's stock prices. So house prices, these are very important applications. For classifications, the problem is something different. Here, basically, the data are splitted into categories. Like here, the output is basically the categorical data, means output the classes. Like I have mentioned just some while means back that there is a digit recognition system or text or something text recognition system where uh, in case of digit recognition system, so we are actually trying to recognize the number from a handwritten image. So someone is written the numbers, and we are trying to find that whether it is 0 or 1 or 2 or something like that. So we have different classes for that, from 0 through 9. So this type of examples uh, are in the group of classification basically. So spam mails, tumor classification is very important. Tumor, uh, just if you have the data for of the tumor's diameter or the tumor shapes, then you can predict whether this tumor is cancerous or benign. So tumor classification is also a very means very good example in this regard. So finally, we came into the steps of machine learning. So there are 7 steps which we have to follow for machine learning. The first, already, if you're trying to means map these two things, that how human can learn, which I have covered in the first slide. That's the means the training, testing, and deployment. These phases. If you're trying to map this with the machine learning, then you can find some steps which are overlapping, right? So first you are gathering data, so your training is means training will start soon, so you are gathering data. And here the representation of data is very important, as I have already mentioned you, that images are means represented as a matrix or a vector for computer. So that representation is very important so that it is understandable by the machine. Preparing that data sometime in a time series data, like if you want to predict the weather, that what will be the temperature next day, so you have already temperatures previously in previous days, so from that you are trying to predict the temperature of the next day. So if you miss any point, if any data is missing, so we have to produce that data. So very important preparation of data, so that the data set should be means uniformly distributed. There is so no there shouldn't be any bias, because from that data actually machine is learning. So if the data is not correct, then machine cannot infer properly. Choosing a model and algorithm is very important. Here I want to give you one example that this algorithm is very much associated with the data set. Like in your class, when you are learning, so some people are very easily learn some topics, but you feel it is difficult for you. But in some topics, you are good. Like, say in electronics class, some people are very vocal. They can answer the questions, teacher's question very fast. They can learn that topic very fast, but you fail on that class. Means you are not that much vocal because you are facing some difficulties to learn the electronics. But in case of optics, you are very fast, so you can learn optics very fast and you can grab that knowledge very fast. So for that chapter, your learning skill is very high, but for electronics your friend's learning skill is Good. So for different types of data sets, the algorithms which we are applying on it can vary, can do means perform differently. So it is a challenge from machine learning that you choose your model or algorithm properly for your data set. So this is very important. Next, the training phase. So finally, we are ready with our data and algorithm. So now the training phase is going to start, and using that data, you have to determine the parameters. So how well you are learning means you are giving a proper weightage on proper parts of the topics. So if you fail to answer the teacher's question in the time of uh, your testing, you have to go back to that chapter and read it well. So you have to give emphasis on this chapter so that you can do better next time. So those are the parameters means for machine means for machine when it is learning, there are some mathematical equation formulation. So for that mathematical formulation, there are some weights. So the machine need to tune that weights so that it can learn better. So I'm not getting very deep into it, just trying to give you some idea. Uh, so next, the evaluation, the testing phase, where you are actually testing your skill on the test data, that whether you are performing properly or not. If you are not performing well, then you have to tune your hyperparameters. And finally, the deployment of the algorithm or the model, and the model uh, is starting to predict new values. So these are the 7 steps of machine learning which we follow. And I will give you the hands-on session, I will show you that how actually the algorithms are learning. Next, why we are shifting from machine learning to deep learning? What is the limitation of machine learning so that we need something more? So in case of machine learning, I have given an example here. So if you want that machine learn uh, about the tomato and the cherry, right? So machine can predict whenever it sees some vegetables, it can predict, yes, this is tomato. When it sees some means bunch of fruits, then it can identify the cherries from that fruits. So for machine learning, you have to uh, tell the machine the features of this means shapes or images. So this is the image of tomato. So from here, what you can grab, what information you can grab, like it has a size, it has a diameter, it is in a means in a spherical shape, so it has a diameter. And for cherry, it is a small one, its diameter will be smaller than tomato, and it has a different stem type as well. So these are the features which need to be extracted by the human. So here, the machine in machine learning, for the feature extraction, you need human intervention. So after that, machine learning will learn this feature of tomato and cherry. Then when you will give a new image to machine, then it can tell, yes, this is tomato or it is cherry. So the human need to extract these features for machine. But in case of deep learning, which is the extra thing, is it doesn't require any human intervention to extract the features also. It can, by its own, can learn the features through a neural network. You can see here, this network of different nodes. So by these layers, it can grab the features from the input data. So this is a very important discrimination because uh, deep learning doesn't need any human intervention for learning. So how it is extracting the feature? So how deep learning works? Let us take an example like in a kids classroom, kids are asked to write numbers by their teacher. So every people write the number 9 in different way. You can see here, right? Different way. But how can machine learn? But a teacher can by just seeing these numbers, a teacher can readily understand that it is 9. But how can machine know? Because these are different. These images are different. So the machine requires the actual structure of 9. So what will be the structure? That is learned by this type of a complicated network. And finally, this is the input layer. So here you can see this is an image of 9, which is a 28 cross 28 pixels. So the total is 784 pixels, and all the intensity values are going as an input to this network. And by this complicated neural network, you are trying to means output that whether it is a 0 or 1 or 2 or 3 or something like 9. So these nodes are very important. Basically, these nodes are identical with our neurons. What the neuron is doing on our brain, it is actually it is actually delivering some or transferring some electrical signals to other neurons. So samely, these activation units, these are the functional units. These functional units are actually delivering some information to other layers. So this way it tries to learn the 9. So if we try to see that what the feature map of 9. So 9, this first this image is broken into parts. You can see here different edges or different lines are extracted from this image. And then this is the first hidden layer. So from the first hidden layer, then in the second hidden layer, you can see these three parts are actually grouped into this loopy pattern. So in the digit 9, what there is a loopy pattern, there is a vertical line, and there is a diagonal line. So this is basically the structure of 9, right? If we try to get the feature map of 9, we have to use some filters. These are called convolution filters. So these filters actually scan these images and try to extract different parts. So here you have this loop. So this filter is actually the loopy pattern detector, and it will give you a 1 if the loopy pattern is present here, and also the position. So you can see from the 784 pixels, means the 28 cross 28 image, the data is actually shrinking. Now it is only this much data. And every time one convolution filter is used, the dimension of the image will reduce. So that way, finally, we came to the output layer that whether it is 9. So if it is 6, then the loop pattern will be there, will be at the bottom. If it is 9, then the loopy pattern will be in the top, and there will be a vertical line here, so in the middle, and then there will be a diagonal line. So for 9, the feature map is basically 3-layer feature map is this. So one is this, one is this, and one is this. This is a 3-layer feature map for 9. So for each of this digit, like for 8, there is a two loops there. So the loopy pattern will return 1 in these two positions, top and the bottom. For 96, it will be one loop is there and another loop is here for 6. So this way, the machine can learn any numbers and can return that particular number. So like this, we can detect alphabets also. For ABCD, there is a pattern. We have to read that pattern. So this way, machine tries to learn the feature of the input. So I'm not going much deep into this type of problem because it will be difficult for you to understand after this, because I have prepared this slides for the students. My target audience are the physics students, physics BSc students. So for them, it will be hard if I go more deep in this direction. So I want to move to the main portion, I think, which is the which is the most relevant topic for this talk. This this is the application on physics, application of machine learning on physics. So I have picked 4 very popular problems here. So materials, different materials are formed with different atoms or different particles, right? And you also know the X-ray diffusion system, which is also called Bragg diffraction. Bragg diffraction. So this type of diffusion, if X-ray is diffused on some material, that uh, event gives us some kind of profile of that material. It can be 2-dimensional or it can be 1-dimensional profile. So from that profile, what we are trying to know the characteristics of material. Means from the shape of the particles inside it, we can try to gather the information that how the material will react or how the material will can be categorized. So here we can use machine learning by uh, seeing the data, like seeing the profile of the material from that Bragg diffraction technique. We can try to identify the different phases of the material using classification technique. I'm coming deep to means I'm going to discuss it more so that you can get some more idea on this. So another problem I have chosen here is estimating the redshift of galaxies from survey data. So you know redshifts. Uh, do you know redshift? Can you give me any idea of redshift? Anyone? Sorry. Do you know redshift? Anyone?
When the light coming from the stars gets stretched due to the acceleration in the universe, the light shifts towards a higher wavelength.
Yes. So from that wavelength or from the frequency of that electromagnetic wave which is coming from galaxy, we can estimate the distance of the galaxy from our galaxy, whether it is moving far from our galaxy or not. So we can estimate that thing. So here, if we have the data of means that the data is captured by the spectroscope and by those waves, or the wavelength or the features of those waves, we can try to predict the redshift of that galaxy. So if we have already a good amount of data with us, which is already means which is already labeled, which is already have the redshift value with the particular wavelength of that means the waves, electromagnetic waves, then for new wavelength we can try to predict the redshift. So thank you for your answer. Next, we are picking again a popular problem in physics, which is determining the micro cracks in materials using again the X-ray scattering data, and where ML can be used to learn or to check that whether the micro crack is present or not. So again, it is a binary classification problem, that if the crack is present, it will give output of 1. If it is not, then it will give us a 0. Next, the problem is removing noise from microscope data. So we know that microscope data is used in different fields, not only in physics, biology and chemistry as well. So for this type of fine data, means these are very teeny dots are very important for this type of data. So if noise are there, maybe some anomalies will be means cannot be noticed. So the it is very important to remove the noise from the microscope data, right? So for that, we can use ML, or we can use neural networks, which uses different filters. You have already seen that different convolution filter can be applied to images in case of deep learning or neural network. So we can use a series of filters on microscope image, and we can able to remove different types of noise from it. So let's explore the problem little deeply. So this is the problem 1. Sorry, just give me a moment. So the first problem is application of ML in material science. So where you can see here is the Bragg diffraction. So every material has different atoms or particles there. They are organized in a particular manner, and if we diffuse the X-ray to the on this materials, then it will refract it in a particular refracted and give us a particular pattern. So from that pattern, we can try to know that which type of particles are there in this material. So here you can see this is a shape of sphere. There can be a rod-like structure. There can be a parallel pips. So these different structures give us the idea of different particles in the material. So the idea here is researcher try to experiment where they are using ML algorithms on this type of data, and tries to see that whether the ML algorithms are performing well in this type of data and can give us the idea or give us the particular class of that particle, so that we can characterize the material. So the idea is that there is a SciML suite, which is a benchmark system, which is basically a set of machine learning algorithms, machine learning, neural network, and DL algorithms basically. So these algorithms are applied to this type of data, and the performance of these algorithms are measured and the researcher tries to know that which algorithm works good for this type of data. So here the data set is basically, this is a simulated data set, contains 10,000 one-dimensional profiles for spheres and 10,000 one-dimensional profiles for parallelograms. So out of this, means we break the data set into two parts. The first one is the training set, which is the 16,000 data. So in total, it is 20,000 data. So 16,000 data are taken for training and 4,000 is for testing. So from they are given this type of one-dimensional profile to the algorithm, and algorithm, by means seeing these features, it tries to say that whether it is sphere or it is a rod-like structure or a parallelepiped. Here we are taking actually only spheres and parallelepipeds, but we can look into other classes as well. So this is the application of ML algorithms to this type of problems from material science. Problem 2, it's basically from the field of astronomy or astrophysics, you can say. So to obtain the accurate photometric redshift, estimate the redshift from the wavelength of the electromagnetic wave which is coming from different galaxies. So the focus is how well different machine learning methods scale or perform with the ever increasing amounts of data. So why we are using ML here? Any idea? Why we are not using physical structure like physical model, the classical data analysis techniques? Why we are using ML here? Okay, so we are using ML here because the amount of data need to be processed. So you can see here, it's millions or billions of data because there are millions of galaxies in our space. So from those galaxies, the data is coming and we have to estimate it. So by means it takes much time when we will use other programs, other means physical structure to to get the solution. It will take much time. But if you feed this type of machine learning algorithm, and we know that now the computation power is quite improved much better than what is there in 1940s or like that. So now we are working with GPU or TPUs. So, and we have plenty of memory to store this type of huge data set. And with this advanced computing power, if we apply machine learning algorithm in this regard, then we can get the result very quickly. Means for human being, it may takes like months to analysis this type of data, but for for machine, it can be like days or only 1 month to for this type of processing. So here is the idea of applying machine learning algorithm to these huge data centric problems. So in this work, almost 1.6 millions of galaxy data is used with spectroscopic data, which is spectroscopic data and used by the ML algorithms. The spectroscopic redshift was required as it was taken to be, means we have used the historical data. Here the researcher have used the historical data that already we have those redshifts. which is used as the ground truth, means which is used like a level. They are already there, and now we have to predict, means it is a kind of regression problem. You can see here the regression problem. Yes. So we have many data points. So if we think like this, if we put lambda in x-axis and redshift in y-axis, so there will be such points, like millions of points are there. So we have to fit a function that can predict, when we give new lambda, the value of redshift. So it is a kind of regression problem which is used here in this case. So we can see there is millions of uh, points, data points, and different ML algorithms are used, like linear regression, k nearest neighbors, multi-layer perceptrons, and like this. So uh, different algorithms has different performance metrics. So according to that, we will choose. So here the random forest works, uh, means it's the best algorithm for this suit. So it gives the most accurate result. So the accuracy is highest for random forest algorithm here. So this is the output of this experiment, which is done by the researcher. So in my references, I have give you the means details of this paper, so you can go and you can see these papers to learn more about the actual thing, because I am not a physics person, so the physics thing I cannot explain you properly, but how the machine learning is working, that I can give you the idea. So determining micro cracks in materials. So here another example of X-ray diffusion. So if again we use the X-ray diffraction technique on materials, then we will get some images of that particular materials, the internal structure of the materials. From there we can uh, extract the features by deep learning or neural network. As you know that, as we already discussed, that from the image of 9, how we have extracted the features. So that way we can extract the features from this kind of images, and we will get some features value here like this. And if we again if we feed this to again another network, then it will output us that whether the crack is present or not. So first you need to extract the features from the images, and then you have to feed that to another network, another neural network, to get the final result, whether it is again a binary classification problem, so whether the crack is present or not. So for determining surface cracks in mechanical experiments, the first step, the images of the deforming specimen surface are analyzed to compute statistical image characteristics. Subsequently, a neural network based classifier is introduced to discriminate between images with and without cracks. So these are very important experimentation, because we know that micro cracks need to be determined, because if we want to create absolute vacuum, like in aircraft or in rockets, so we need to we cannot have any external interference in this type of system. So we need to determine the micro cracks, means which are not visible by our eyes. So this problem is very important one for this type of domain. So we can use machine learning here as well. And the last problem which I will discuss today, that is removing noise from the microscopic data. So here, what I have already mentioned, a series of filters are used. Like we have different filters like Gaussian filter, low pass filter, high pass filter. Different filters are there to denoising images. But one single filter is not enough for denoising every type of noises from images. So obviously, a series of filters will work better here. So image processing by convolution neural network takes the form a series of convolutions that are applied to the input image, which is better than the trivial one that using a single convolution may appear to be an almost trivial image processing tool. Successive convolution can transform the data into different mappings. So uh, convolution filter you have already seen here uh, in this deep learning thing, that there is different filters for extracting different information from the image. So we can use our own filters to denoise the image accordingly by the study. And here this experimentation is done, and the output is like this. So this is a noisy image where you can see this is a microscopic image. Here there is many noise, is not very visible. So when the denoise function is used, like it is restored, then you can see very well the age or contours of these anomalies, like these particles. This is the original image, and means after capturing the image, when you shift this data to some other device, the noise is introduced on that time. So every such machines or every such capturing device has its own uh, means noises which is introduced on these images. So actually this looks like this, but when you capture the image with and transfer it to some other device, it will look like this. So we need to restore it. Okay, so we are almost there in our hands-on session. So I have chosen Python here. Why I'm chosen Python here? Because Python is a very easy to learn language, because the instructions are almost like a natural language. So it also takes very less time. If you code it through C or C++, this type of machine learning algorithm or deep learning algorithm, it will take thousands line, maybe more. Thousand is means a lesser number for it. So thousands line of code for this type of machine learning algorithm is C, C++. But in case of Python, you can see, I just going to uh, give you the idea. So you can see it's just a set of instructions only. This set of means uh, 10 or 15 lines through which we can give you the result. So Python has a very rich library. Different packages are there, like NumPy, SciPy, which are very important for scientific research, scientific computations. There are other importance or other benefits of Python as well, like it can be used in machine learning, big data, network programming, and many more. So for this reason, I have chosen Python for this hands-on session. So here I have just given you two examples, that if you want to print 1 to 1000, then you have to write a C code like this. You have to include the header files. You have to declare your variables. This is a very simple, very simple example. And then you have to write your loops and all that. So it has a structure. But in Python, you can only write one-liner code to print this type of series. So this is my example one, and another example I have taken for the intersection of two lists. We want to find out the intersection of two sets or two lists. So here This is my C code where I have taken two sets, and this is my loop, which is actually checking whether the elements are equal, and if it is equal, if it is in both list, then it will return that value. But in Python, you can see this again a one liner code, a one liner function. Using this, you can return the intersection of two lists. So this is basically the application of the function. And just to give you the essence that why we are using Python, why now Python is a hot cake. Okay, so let's move on our hands-on session. So these are the references I have used. I have actually given you the papers as well. You can see here what I have gone through. And these are some YouTube channels which I have gone through for this study. And there is a deep learning book from MIT, from Goodfellow, who is called as a father of deep learning. So you can follow this book to learn deep learning in more deeply. So good luck for your exam and thank you. So I'm waiting for your question. Before that, I will give you some hands-on idea. So let's see, let's explore. Okay, so I have already prepared some code for you. So I have taken actually two examples, one for supervised learning and one for unsupervised learning. So for supervised learning, here this is the logistic regression problem. So I want to show you the code. Is it visible? Is the code is visible?
Yeah, it
Yeah, it's
yes, it's
visible.
visible now.
Okay. So that can zoom it or not. Okay. So this is the code. So here what we have done, I'm just demonstrating you the code a bit. So here what we are trying to do, we have diameters of tumors as the input. So these values are the basically the diameters of the tumors. This is the input value, and we are trying to give the answer that whether this tumor is benign or cancerous. So if it is benign, then it is 0, and if it is means not cancerous, and if it is cancerous, then it is 1. So we are trying to classify this data by this logistic regression algorithm. So it is a machine learning algorithm. So you can find this type of model in sklearn package. You can use it very frequently. So sklearn provides you all this type of machine learning, deep learning models. And here we have used the NumPy also, because we have used the NumPy array for taking the input vectors and output vectors. So here I have handmade this data, but you can use any data file. You have to just search for the code for your file, that how you will convert it to the means algorithms understandable way, that you have to find out. Here I have just handmade this code, this input. Then I'm calling the logistic regressor here from linear model, and this is my training phase. This code is basically the training of this model. So this logistic regressor is fitted with this data, this x and y. X is the input vector and y is the output vector. Then basically, after this training, we are predicting the value. We are given a new data that is 3.46. So what should we get? That whether it is cancerous or not. So I have printed the predicted value. And first see the output of this. Then I will give you the idea of this part of code, right? So I'm just running this code. So it will take some time because it is importing the packages. So yes, just look into the first result. Look into the first result. It is 0. So it is predicting 0 for this 3.46 value. So if the diameter of the tumor is 3.46, then it will be a non-cancerous tumor. If we change this value, like if we change, let's see what happened. If we make it like a bit more, like if we give 6.5, what happened? Let's see. See, if we give 6.5 larger value, then it is predicting as a cancerous tumor. It is 1. And now, obviously, you have the question what these values are. Okay, so let's demonstrate the next part. So, this is actually what is happening in this model. Basically, it is drawing a line here. So, it is a regressor. So, it is drawing a line here. So, the equation is Wx plus B. That is the coefficient W, and B is the intercept of the line. So it is basically fitting this line to this data and trying to classify trying to get the n value. And this function is actually returning the probability that each of this value has what probability of becoming a cancerous or a non-cancerous tumor. Like if it is 3.78, if you look into the result, so if it is 3.78, then the probability of being cancerous is 0.60749955, like 0.6, you can say. So why we require this? This information is very important for doctors because they can, from this value, they can understand what is the status of the tumor, whether it is going to be cancerous or it is absolutely safe. So the doctor can determine the treatment from these values, that the probability of becoming or getting to the particular, so it is giving the probability to becoming cancerous or non-cancerous. So it is, this part of code is giving us a real value, which is the probability. It's not only giving the class, it's giving us the probability of becoming a data or belonging a data to a particular class. So you can use this type of algorithms to fit on your own data and you can predict the answer. So I'm just giving you the idea here. Okay, so going to the next problem, because we are already short of time, I think. So this is a clustering problem. So this is an unsupervised learning problem. So here again we have import sklearn, but for clustering algorithms, sklearn.cluster, from sklearn.cluster we have imported k-means. So there are plenty of tutorials you can follow from YouTube, or from you can search Google for this kind of tutorials where you can learn the Python codes for this, for applying this ML algorithms. So here we have the input and output vectors. So first let's see what is the output of this program, what this program is doing actually. Okay, so what is this? These are the data points which I have handmade here. So these are the x and y axis, and these are the values. This is a scatter plot. So this is very important for you as well. So how the plotting things is happening. So there is a library matplot lib, from where you can means use different plotting scheme to plot your data. So here I have used the scatter plot technique. So you can see here the data are plotted in this coordinate system, xy coordinate system. And now we are trying to cluster the data. So you can see there is two clusters. The two colors are basically representing the two clusters, and we have used the number of clusters here as 2. If we change this to 3 and save it, sorry, now you can see, yes, there is 3 clusters. So we have used the k value as 3. So now there is 3 clusters. So how you can find this value of k? For that, you need to go through this part of code. So how you can learn this k? Okay, so I'm running this code again. Now you can see, yes, this one. So this one is telling how better will be the performance if we choose different case. So here is the number of clusters, and this is the inertia, means the bindness of the clusters. Means by this inertia coefficient, we can actually measure the performance of the clustering algorithm. So if the number of clusters is 2, if it is 1, so the inertia is higher, and it will go down as we increase the number of clusters here. But you can see after a certain time, it is just a straight line. So it will not give a better result. So like from after this value 4, if we use k equals to 4, from there on, for changing the value of k, the performance is not means changing much. So from 1 to 2, there is a peak, means there is a certain change, but from 4 onwards, the change is almost very much less, very much limited. So this is called elbow graph. So for clustering, you can try this type of elbow graph to see that which clustering value, means number of clusters, you can choose, and which can give you better result. Okay, so this is it. This is the end of the hands-on session. So now I will expect questions from you. So, if you have question, you can put it. Sorry,
Uh,
actually, I have taken much time, I think. Yeah,
no,
go ahead.
it's okay. So participants can unmute themselves and directly interact with the resource person. If you have any question, please unmute yourself and ask resource person. There is a comment from Bornali that it was a very nice presentation. Anyway, participants' feedback link is posted in the chat box. Please fill it up to get the e-certificate of participation. Any question from any participant?
Hello, ma'am.
Yes.
It was a very good presentation. Can you give an idea about how to use R programming uh, in the science? Something like that.
Very sorry. I have no experience on R because I'm doing my coding in Python. So basically, for statistics students, R is the language. Uh, I think for
But I see
R,
some articles related to that, like we can also analyze data using the R programming, and it is equivalent to the
yes.
Python.
Because
Like,
yes, of course, you can because there are different statistical model as well, which are strategies are different than the ML or data deep learning algorithms, but uh, means statistical analysis is another way of looking into this data. So that is also very encouraging. You can look into that, but I cannot help you for that. Sorry for that.
okay, ma'am. Thank you. So we can't replace these two. It has different applications. Like that, can we conclude?
No, you can apply this data sets also in the statistical analysis as well. So you have to check the performance of this model, right? There are numerous statistical model are present in this market. So you can try with this type of data sets. You can try those models as well, and you can check the performance which is performing well, whether it is deep learning or whether it is the statistical model.
Okay. Thank you,
Yeah,
ma'am.
thank you.
Any other question? Okay, so in that case, uh, anyway, thank you, Professor Dipanita. Now I like to ask our departmental colleague, Dr. Shubhendu Chandra, to deliver the vote of thanks. Shubhendu, da.
Yes, can you hear me? Hello?
Yes, yes, yeah, you are audible.
Okay. Good evening, all of you. Today we are going to extend the end of the one-day international webinar on how machine can learn physics using Python as a tool, organized by the Department of Physics in collaboration with IQAC Victoria Institution College. I feel very much privileged to propose a vote of thanks in the concluding session of this occasion. On behalf of the organizing committee, extend a very hearty vote of thanks to the Honorable Teacher in Charge, Dr. Umara Srinivasan, Victoria Institution College, Dr. Dipanita Palghosh, Coordinator IQAC, Victoria Institution College, and Dr. Sinjini Dasgupta, Convener and Head of the Department of Physics, Victoria Institution College, who blessed us with their presence in this international webinar. I express my sincere thanks to Dipanita Chakraborty Bhattacharya scholar scientist, visiting scholar, Department of Computer Science, Florida State University, Florida, USA, our valuable resource person for our excellent presentation. Starting from the very preliminary problems in the way she raised her presentation to the height of use of machine learning and artificial intelligence in Python language deserves special appreciation. In a very lucid way, she explained elaborately various theoretical and experimental ideas of machine learning algorithms to some hands-on coding in Python to understand the steps and how they are implemented. Her elaborate explanation of this topic will definitely receive a special acceptance of the students as well as the teachers joined from various colleges, universities, institutions. Thank you once again. I would like to impose my special thanks to our valuable audience. Without them, it is impossible to implement this webinar a grand success. My sincere thanks to faculties and staff members of the Department of Physics of our college for extending their sincere help and support. Finally, I once again thank our respected teacher in charge ma'am, delegates and dignitaries, valuable speakers, respected faculties, and dear students of participating colleges, universities, and institutions. Thank you. Thank you once again.
Thank you, Shubhenduda. Just one thing, Dipandita, Oisharya asked for that can you please share those Python libraries?
Yeah, I can share the codes which I have written and I have shown here. I can share those codes and also the materials which they can like uh, they can also means communicate with me through my mail ID. So if they have interest in this field, they can put me some mail and ask me questions. And also I can share some materials to them one to one as well. So I'm just putting my mail ID here in the chat box. Yes. So you can mail me and I can forward you some materials, useful materials for this. And you can also check the references. I can also share my slides as well. So the PDF file, so that everyone can uh, have access to the link of the papers. So that I can give you, Professor Dashgupta, through
Yeah,
mail,
no
and you can.
problems. Yeah, no problem. And then those who have filled the feedback link, I will send those materials by email.
Okay, okay.
Okay. Yeah, it will be good for them. Thank you.
Yeah.
Okay, then thank you all. So we are closing now. But Nita,
Thank
can you
you.
just
Thank
stay
you
for
very
a
much.
yeah, Deepa, can you just stay for a while?